Stanford University.
All right, so welcome to lecture number 2 of CS193P, fall of 2011. This is not even going to be a lecture, it's just all demo. Okay, so I'm going to dive right into this demo. It's going to take our entire time here. What we're going to be talking about in this demo is model view controller. Okay, we're going to do a simple model view controller, but mostly what you're going to see today is what Xcode 4 looks like and what writing an Objective-C program looks like, including creating our own model view and controller. Okay, so here I am in Xcode. When you run Xcode, you get this splash screen, and you can see that on the right-hand side has a list of all your recent projects that you've opened. When you run Xcode, these will be blank, just like they're blank right here, because we haven't even done our first programs. This is going to be our first program today. There's some other options here which we don't really have time to go into today, so I'm just going to start with this very important option here, which is to create a new project. So I just click on this, and immediately we go into the project creation screens of Xcode 4. This first thing that Xcode 4 is asking us is to choose a template for our application. These templates don't have a lot of code in them, but it's just a little bit. You can see that there's one for creating a document-based application or an OpenGL game or page-based application like iBook-like application. And the one we're going to pick today is really the basic one, probably the one you're going to use most of the quarter, which is single view application. And what single view application template does, it's going to create a controller for you and a blank view, and that's it. Okay, so it's a basic single MVC application. It's going to create kind of a template controller for you and a blank view. All right, and you'll have to create your own, we'll create our own model. All right, so we just click next here. And now it wants to know some details about the project, like its name. So today what we're going to build is an RPN calculator, as I said last time, a reverse Polish notation calculator. And what that is a calculator where you enter all your numbers using an enter key, and then the operations pull the numbers back off of a stack of operations. So for example, if you want to do 3 plus 5, you would say 3, enter, 5, enter, plus. And it would pull the 3 and the 5 off, add them, make 8, and then it would put that back on the stack. And so if you then said 6 plus, you'd get 14, right? So it's just a stack of numbers, and that's what we're building. So we're going to call it calculator. And this next field here, company identifier, that's to uniquely identify your application. And it has this kind of reverse DNS kind of structure. And so we're going to use edu.stanford.cs193p.yourname, okay, because that's pretty unique. Okay, the chances that that's going to conflict, especially like if you use your Stanford ID or something where I have instructor, it's probably going to be quite unique. And this class prefix is, remember, this template is going to generate a controller class for you, and it's going to call that class viewController, which is a pretty generic name of a class. So this is just a word you can put in front of it to make it less generic of a name, and so we're going to use calculator. It used to be that Xcode would just always use the name of your app for this, but now it lets you set it. So now our controller is going to be called calculator view controller instead of view controller. That's all this is. We can build apps here for the iPhone or for the iPad or a universal application that actually will run on both. Okay, so there's mechanism in iOS and in Xcode for building a single application that has 2 different UIs, one for an iPad, one for the iPhone. Okay, which is kind of cool because you want to share a lot of your controllers and all your models and all that stuff. But your views and maybe the way your controllers interact with some of your views is going to be different if you have a lot of screen real estate and you can put a lot of things on screen at the same time versus a smaller phone-like interface. So we'll see that later in the quarter. But for simplicity, we're going to make this one iPhone only. This use storyboard. Storyboard's a new mechanism in iOS 5 that basically allows you to put all your MVC's views on screen at the same time, so you can see how they interact with each other. You remember in the last lecture I had that kind of big thing where I had a whole bunch of MVCs talking to each other in a good way. Well, what storyboards allows you to do is kind of see that on screen at the same time, so you can see how your MVCs are interacting. It's really pretty cool. And then automatic reference counting is even cooler because in iOS 4 you had to manage the memory for all of your objects yourself using reference counting, and it was quite tedious. And automatic reference counting, the compiler does it for you. Okay, it manages all the memory, when memory goes away, it comes and goes, just with that strong weak thing, and it's quite remarkable. We'll always want this checked. And then unit testing we might get to towards the end of the quarter, but we're not going to be doing it right off the bat. All right, so we click Next. Now it just wants to know where do you want to store your project. And I strongly recommend that you save it in a directory called Developer, okay, inside your home directory. So here's my home directory, CS193P, and here is the directory in it called Developer. And so you can use New Folder to create that here if you don't already have it. And so when I click Create here, it's going to make the folder that contains my calculator, that folder is going to be called Calculator, inside my home directory / developer. Okay, this is a great place. Highly recommended you put stuff here. Down here you see source control. We are definitely going to talk about source control. It's really well integrated into Xcode 4, but we're not going to do it for this very first project, so leave that unclicked. So I'm clicking Create here, and boom, we created our project. Now, this initial screen, I'm going to go full screen. I'm running Lion here, so I'm going to go full screen. There's a lot of stuff on screen right here, a lot of things about icons and stuff, and that's only half of it. There's all these settings, build rules, build phase, all this. We're going to get into all this as the quarter goes on, but we're not going to talk about any of this today. What we are going to focus on, though, is on the left. If you look on the left, this area here is called the Navigator, and it shows you all the files that are in your project, and you can group them by folders and things like that. We'll see that as the quarter goes on as well. And we're not going to look at any of this except for these three files, right? Main storyboard.storyboard, you see that? And then calculator view controller.m&h. Okay? So main storyboard.storyboard, that's where our view for our MVC is going to be. In fact, all our views for all our MVCs are probably going to be in our main storyboard in this class. You could have multiple storyboards and separate your MVCs into groups, but that would be a pretty serious application to have that many. So in our case, our storyboard is going to contain all the views for our controllers. And then calculator view controller.m&h, you'll remember from last lecture that when you have a class, it has a header file, .h, and it has an implementation file.m, so that's what those two are. So there's our controller, here's our view, and we're going to create our model later. Okay, it doesn't create a model for you because it doesn't really even know what you're doing there. So let's start with our storyboard. I'm going to click on the storyboard, and this view that comes up, you're going to see here, is blank. So this is the view for our controller, and it's blank. You can see that it's kind of iPhone sized. We'll do a lot of talking about sizing and stuff like that later in the quarter, but for now, it's kind of picking a nice size, iPhone size. This little area here is for browsing all the objects in your view by looking at them by name, essentially. This is just the top level view right here. We're not going to look at that in class today, but when you're doing your walkthrough, you can certainly pay attention to that. So I just clicked that little button to make it go away. I also don't need this navigator up all the time. It's wasting valuable screen real estate here. So I'm going to start using these buttons in the upper right. You see these here where it says Editor and View? These are for managing what's on your screen. Okay? And so by clicking this one right here, it says Hide or Show Navigator. I get a lot more screen real estate back. Now what I'd really like is, in addition to having my view on screen right here, I'd like to have my controller's code on screen at the same time, side by side, so I can work with them together because they go together. The view is the controller's minions, right? And I can do that with this icon right here. It looks a little bit like a guy with a tuxedo. It's supposed to be like a butler or something. This is your assistant editor, and if you click that, it's going to have two places on screen to view two related things. It's important to realize that it's trying to, Xcode as you move around, will try to keep these two things being related, and we'll see that a little bit as we go along. And this bar in the middle can be moved, right? So you can make more space, move your view off to the side so you get as much room for code. I have a very large font here so you can all see it. So I'm going to make as much space as possible there. Now, you should recognize this viewController.h from our last lecture. So here's that @ interface. Here's our superclass. Our superclass were imported from this framework header file that I talked about, UIKit. And we currently don't have any public API here. All right? And we'll look at our implementation file in a moment. So we're going to dive right into building our user interface for our calculator. And to do that, we obviously need some buttons and a text label area so we can have a display on our calculator and things like that. And all of that comes from this little button on the right, in the upper right corner here. When you click on that, it'll bring out another little space. And this space really has a top part and a bottom part. This top part is called an inspector, and it's for finding out more information about what's selected. So if I select on my view here, I'm going to get information about my view. You can see this is view attributes. Again, we don't have time to go into all what these are today, but as the quarter goes on, we'll see these more and more. And then at the bottom is, you can think of as like a palette. Okay, a palette of things that you're going to paint your view with. It's a palette that has things like code snippets and things like that in there as well. And down here, we're going to want this. You can see that the different palette things are here. We're going to want this one, the one that looks like an object, because we want an object library here to choose from, because we want to get our buttons and stuff like that. So if you look in this object library, there's quite a bunch of stuff in here, so sliders and switches and web views and table views and all that. And we'll cover it all in this quarter before we're done. But the one we want here is just called label. Right? A label is a static, read-only text field. And if you want to put one into your view, your controller's view, you just pick it up with the mouse. And when you start to drag it, you can see it's kind of get a little fading in and out. And as I drag it over towards my view, you can see that it's actually going to put little dashed blue lines to help you line things up. Right? So make sure it's not too close to an edge, or if you want it right in the middle, things like that. So we'll use the blue lines and put it right here. This label is a good start, but it doesn't look much like a calculator's display to me, so we have some work to do on this thing. First and foremost, it's too small. We don't want it up in this upper left corner like that. So if you see these little handles around the edges, I can pick these up and move it and resize it, and so I can even use the blue lines here to get this to be some size that I want. So maybe, I don't know, 40 pixels high or something like that. We also don't want this to be left aligned. In any calculator you've ever seen, right, the numbers are all right aligned. They come out of the right side of the screen. So how do we do that? Well, now we are looking at this inspector over here on the right, attributes inspector. And you can see there's all kinds of things we can set, including the alignment of the text. So I'm just going to click on this to right align it. I also see the font right here, so I'll use that to make this a little bigger, maybe 24 point or something so I can see it better. And I certainly don't want the word label coming up in my calculator, so I can just double click directly on it, change it to a 0. That might be that's probably a good starting value. And so just like that, I have a text label that is going to be used for my display. Now, I need to be able to talk to this thing, though. All right? And in fact, if you remember from the MVC picture we had before, the green outlet is the arrow that has our controller talking to objects in the view. And our controller definitely needs to talk to this display. It needs to tell it what to display, right? Tell it the results of calculations, and also as you're typing numbers in, it needs to be updating, all right? So we're going to create an outlet from our controller into our view. So let's go do that. The way you do this is not by typing in code and all that stuff. You actually do this with the mouse. So the magic thing here with this finger is I'm holding down the control key on my keyboard. Don't forget to do this, okay? You've got to hold down the control key, and then you just control and drag a line from the display into your code. I know this seems weird. Mixing graphical with the code, but it's really pretty cool, actually, when you get used to it. So we're going to drag it in here, and then I'm just going to let go. And it's going to say, oh, you want to create an outlet. You see right there it says connection outlet. And it notices you want to create it to your controller, of course. And it notices that it's a UI label. Right? This is a connection from a UI label to your controller. And the storage here is strong. But actually, I'm going to make the storage. This is the property thing we're talking about. I'm going to make the storage of this pointer, because it's going to be a pointer to an object, a pointer to a UI label. I'm going to make it weak. And why am I going to make it weak here? Because this label already has strong pointers to it because it's in that window. Okay, that window, which is the super view basically of that label, already has a strong pointer to it. And if it doesn't have a strong pointer to it, then I don't even want to update that display, because if it's not in the window, I don't even want it around. So I only need a weak pointer to this. I don't need that label to stay around unless it's in the view, right? So I'll make that weak, and usually outlets we're going to make weak. Okay, almost always weak. And it also wants to know a name for this outlet, and since this is the display of my calculator, I'm just going to call it display. All right, so I click connect, and you can see that it has made a property. And hopefully you recognize this syntax from last time, right? Here's it's a property. It's weak, not strong, but weak. Non-atomic, this is this thing, not thread safe, we don't care. We do have this little word right here, IB outlet. This is type deft to nothing. All this is, Xcode puts this in there so it can keep track of which properties are outlets. But the compiler does not even look at this, okay? It's just type deft to nothingness. So don't even worry about that. And then here's the type of this property. It's a UI label star, right? A pointer to a UI label, which is exactly what this is. And this is the name of the property, which is display. Now what's really cool here is you'll notice there's this round circle to the left. And if you mouse over, you don't even need to click on it, just mouse over it, it'll show you what view this display property is hooked up to. Okay? So that's a cool way, and especially once you get a bunch of properties, it's really cool to see which ones are connected to what. All right, so this is the declaration of this property. Let's go look at the implementation of this property. And to do that, we're going to switch over from calculatorViewController.h to calculatorViewController.m. I'm doing that just by going to this top bar right here and clicking on the name and switching it to the .m. And we'll make a little more space here. Move this over again. And you can see that the template for our view controller is put a bunch of stuff in here. We don't want any of this. Okay, so we're going to get rid of all of that. We do want this though. You see that it added the implementation of our property @ synthesized display. Didn't quite do it the way we want, but it's a good start. But everything else in this file, I'm just going to delete. All right, because none of it we're not going to use any of it in our first application here. So I'm deleting that. Make spaces display a little bit. So this is clear. Now, what has Xcode not done here, though? It hasn't done what I said you always need to do, which is to use the equal sign to specify a name for the instance variable that's going to be used to store that pointer to be something else besides the name of the instance variable. Question?
In general, do you want to delete that stuff, or is that just for parentheses?
The question is, do I want to delete that stuff from the template all the time? It depends. You're going to find later in the quarter, you're going to use some of it. Or, you know, it's all stubbed out. It doesn't actually do anything. It's just like those methods are there for you to fill in. So it's going to be up to you. If we left them in there, it wouldn't have done any damage. It wouldn't have hurt anything. But I just want you to be clearer code so you can see what's going on. So we synthesized our display. That's awesome. Okay. So our controller's ready to talk now to our label here anytime it wants to. And remember that synthesize creates the setter and the getter. Now, when is the setter going to be used for this property, and when is the getter? Okay, the setter is going to be used by iOS to set this pointer. When the storyboard gets loaded up and this thing appears on screen, it's going to call the setter to create that connection to that label. The getter, we're going to call in our code anytime we want to talk to that label. We're going to call the getter, get the pointer to it, and send it messages. And you're going to see that. All right, what else do we need in our UI here besides this label? We also could really use some buttons. Okay, for example, we need some buttons to be the keypad of our calculator, the 0 through 9 buttons. So I'm going to go back over here, get my palette of objects back, and instead of dragging out of a label, this time I'm going to drag out this round direct button. Okay, so I'm going to drag this over here. You can see the blue lines are helping us again, and I'm going to listen to the blue lines. And I'm going to resize this to be 64 pixels wide. Turns out to be a very good size, turns out. And so this would be a digit button, like this might be the 7 button, okay, in the upper left corner of a keypad that's right here. And now we need to think about a different kind of connection between our controller and our view, which is this target action thing. So we need to kind of hang a target on our controller so that the buttons, these keypad buttons, can send an action to it and get it to do things as the user is touching the buttons. So how do we do that? Same way as the outlets. I'm going to hold down Control, right? I'm going to drag out, and this time it notices, oh, we're dragging into the implementation. We probably want to insert an action here, and it's right, we do. And so it notices it's an action. We're not going to talk about the stuff at the bottom here quite yet, but we do need to give this action a name. And I'm going to call this thing digit pressed, because that's what it is. They're touching this button, and it's a digit. It's one of the digit buttons. So I'm going to hit connect here, and we're going to get this code. We're going to look at this code, see what it's all about. So this is a method declaration. Again, similar to what you saw in Tuesday's lecture. This return type might be somewhat disconcerting. You might say, IB action, what kind of type is that? Well, actually, that's type def to void. All right? Target action messages do not return any value. The reason this is type def to IB action instead of void is, again, just like the IB outlet, it's just in there so Xcode can remember, oh, yeah, this is an action, versus just being a random method with that kind of arrangement of arguments. This is the name of the action, digit pressed, colon. This is the type of its argument. Okay, so this is very important to understand what's going on here. This target action message, when the button gets touched and it sends this message to our controller, it sends the message along with an argument. And the argument is the object sending us the message, the sender, right? A button in this case. So you might be saying, what is that id in there? Okay, what is id? And in Objective-C, ID is a very important type. Okay, it's a type. It's primitive type essentially, but built-in type to Objective-C. And what ID is pointer to any kind of object. Or you can think of it as pointer to unknown class of object. Okay? So any object could be passed along here. Now, that can be a good thing, as we'll see next week in your homework assignment, or it can be sometimes not a good thing. And so today, I'm going to leave that ID for right now, but then I'm going to change it, and you're going to see why it was good and why it was bad. All right, so I need more of these keypad buttons. So actually, I'm just going to copy and paste them. So copy, paste. Copy, paste. You use the blue lines. I can actually copy 3 at a time. Paste those. Okay, paste another 3. And quickly build up my keypad. All right, and then change the title just by directly double-clicking on them. 8. This one is 9. 4. 5. 6. 1. 2. 3, and 0. Okay, now, one thing that's interesting to note here, oops, not 0. One thing that's interesting to note what's going on here is that all of these buttons are going to send the same target action message. When you copy and paste a button, it copies and pastes its target action. So if I put my mouse over this property, remember we saw the label, and if I go into the implementation file and put it over this, all the buttons send this message. Make sense? So they're all saying that's because I copied and pasted them. So when we add operation buttons and the enter button, we don't want to copy and paste a digit button, or it will be sending that. And yes, a button can send multiple messages. So you certainly wouldn't want your operations button sending digit press and operation pressed at the same time. Okay, so we're going to be careful not to copy and paste digit buttons to make operation buttons. Okay, so let's start doing our implementation of digit pressed. Okay, so we're going to start seeing some Objective-C being typed here. So I'm going to create a local variable, which is a pointer to a string object. Okay? So NSString star means pointer to an NS string. Digit is the name of the local variable. By the way, obviously arguments show up like they look like local variables inside your implementation, just like in any other language. So we have a local variable called sender, which is the object that sent us this message. Now, what I'm going to do here to get the digit so I know which digit was pressed is I'm going to send a message back to the sender, and I'm going to ask it what its current title is. And that's how I'm going to know which digit button was pressed. So open square bracket to send a message in Objective-C. Sender is a pointer to the object that I want to send the message to, which is the object that's sending me this. And now, as I start typing, watch what happens. Okay? So I type C, U, and I start Objective-C, or really Xcode, is showing me all the methods that it knows about that start with CU. And there's quite a few. But most of these are not button messages. I can't send these to a button like currency symbol. That's not a button message. Or current request, current minimum track image. These are not UI button messages. So this is a lot of junk right here. And if I typed one of these, I wouldn't get an error, but it would be wrong. So this is where ID can be a problem as a type, right? We know that this code only works if a button sends it to us. Like if a slider sends it to us, it's not going to work because we're going to ask the thing for its current title, and the slider doesn't have a current title. So that's going to crash. I'll crash my app even. So I can change ID here to be UI button star, pointer to a button. And when I do that, and I go back here and I type CU, now I'm only seeing methods here that button responds to, these 5. Right? Current title, current image, etc. And in fact, I can pick one of them, like current title, which is the one I want, and then use the tab key. I'm using the tab key now to finish the escape completion, basically it's tab completion, and close square bracket. All right, so now I've gotten the title of the button, and I've copied it into this local variable, digit. And what I'm going to do here real quick to show you a little debugging tip is I'm going to send this digit to the console, okay? Because that's a really easy way to debug. Most languages, you maybe have done this way of debugging. It's a little easier than setting breakpoints and stepping through and looking at variables. This way you can just print things. So I'm just going to do that, and the way you do that is with the function. It's not a method, it's a function called nslog. And nslog is just like printf. You all know what printf is, except for that instead of taking a const char star string, which is a formatting string, it takes an ns string. And the way we specify a constant ns string is @quote. Okay? So @quote, this is a constant ns string. And we can put inside it something like digit pressed equals. And then we can put percent formatters like %d for integer, %g for floating point. We never use %s because %s is const char star or char star. Okay? But we do use a very special new one called %@. And %@ means the argument that corresponds to this printf formatting thing is an object. All right? And what nslog is going to do, it's going to send the message description, very special message. It's going to send the message description to that object. That description method has to return an ns string, and it's going to use that ns string to display this particular %@ right here. Now, ns string returns itself from the description method. Does that make sense to everybody? Why it does that? Because it's supposed to return a string describing itself, and it is a string, so it returns itself. So here we can just say digit, and we'll get whatever string is in the digit, which will be the current title of the button. So let's go ahead and run our program for the first time and see if this is working. So to run our program, we go to this button in the upper left-hand corner called Run, and it looks like a play button, and we hit play. And this is the first time we've run it, so it's going to be pre-compiling some headers and loading the frameworks in and all that stuff. So you can see it up there. It tells you what it's doing up on the top. See, it says pre-compiling 1 of 1 prefix headers. Xcode, really great about pre-compiling things, caching things, so that when you do something a second time, it's always much, much quicker. And here it's linking. Now it's copying resources like our storyboard and any images or stuff like that. And it succeeded. Now, we're going to run this. You can run this on the device. If you look at this, you see up here where it says Calculator iPhone Simulator 5.0. You can run on a simulator, which is fine for your first 5 or 4 or 5 homework projects. Or you can actually, from this pop-up, pick to run on a device. But if you run on a device, you will need to join the developer program, like the Apple Developer Program or University Developer Program. So actually, I'm going to go back and go into non-full screen mode here, so we can see both the code on the screen at the same time as the simulator. Did I click that? Yeah. And sorry. All right, so here's our simulator. So the simulator, you know, it's not exactly the same to run something in the simulator as it is to run it on the device, but it's pretty darn close. Okay? So here's our simulator. It's going to load that storyboard up and run the application. So here it is. Now, before I start touching any of these buttons here in the simulator with the mouse, I'm going to show you the console, because the whole point here is we've got the NS log in here that's going to show you to the console. Where is the console? Well, if you look down here at the very bottom of the screen, this bar down here is the combination debugger and console. And when you run, it appears. And when you stop, it disappears. And if you want to see more of it, you can use this little button right here. Okay? You can also use this little button in the lower left. We're going to use this one up here. So we click that, and it appears. This is showing right now all the variables in the debugger, local variables in this case, none. You can have this little button right here to show the variables and the console, right? And we can move this thing. Or you can just say console only, like this. And so here's the console. Nothing has come out in the console. Things that you generate will be bold in the console. So let's go ahead and go to the simulator and touch something here and see what happens in the console. So let's try 5. And you can see digit pressed equals 5. And every output, every NS log is time-stamped to the millisecond there. All right, so you can see what's happening. Okay, so there we go. We ran our first app. Very simple, very straightforward. All right, so let's stop that. Let's go back to full screen mode. Now what we're going to do is get rid of this NS log and put the actual implementation of digit pressed. Now, we're a little running behind on time, so I'm going to go through this pretty quickly. This is really just one line of code is all we need for this digit pressed. But I'm going to break it up into 2 or 3 lines of code, and then we'll combine them just so you can see what's going on. So first, I'm going to create a local variable, a UI label called myLabel, or maybe it's better called myDisplay, possibly. And the way I'm going to get the value to put in this pointer is I am going to send the getter for our outlet, right? We have this outlet to the label. I'm going to send the getter message to self. That's how I get the label to be able to send a message to it. Now, I don't really need to create a local variable here to put it in, but I just want to show you what it looks like to call the getter. And in fact, I told you there was a special syntax for calling the getter, which is that dot notation. Remember that at the very end of the last lecture? So let's use dot notation. That looks like this. Okay? So the self.display is exactly the same as open square bracket self-display. It's calling the getter. That's getting the pointer to the UI label. So now that I have the pointer to the UI label, I'm going to get the text out of it, because when we press digit buttons like 5, 6, 8, 9, really what I want is I want those digits to be appended to what's already in the display. If I've typed 56 so far in the display and I type 2, I want it to be 562. So I'm going to get the text out, append the digit they just typed, and put that back. That's all this method needs to do. All right. So let's have another local variable, NSString. How about we'll call it current text. All right. To get the current text, I'm just going to send a message to my display called text. Okay. Text is a method that is understood by UI label that says, give me the text in yourself. Now, this might be a good time for us to take a really quick aside and talk about the documentation. Okay. The documentation is very easy to access. The magic here is the option key. So I'm holding down the option key, and when I do that, if you notice, when I mouse over methods, look what happens. They turn into links. See how they're little links? I don't know how well you can see that, but they're turning blue with little dashed underlines. And if I click on one, like text, then I get a little pop-up window with kind of a little mini quick help on this particular guy. So here's text. Notice that it's an @ property. So this is actually the getter of a property. So we're probably going to want to use dot notation here, which we will in a moment. But also notice that everything in the quick help, it's got a little description of it, it's a link as well. So if I wanted to find out more about the NSString class, for example, I can just click on it here. And that's going to bring up the full documentation. Okay? So here it is loading up the full documentation on NSString, the full class reference. And these references are awesome. These really, you want to spend a lot of time studying these guys, okay? So here's NSStrings. Notice it tells you what the superclass of NSString is, and shows you a bunch of sample code here, which is really great, and various companion guides, like the string programming guide, how to program with strings. Here's an overview of the class. Here's all the methods that NSString implements. A lot, okay? NSString, a lot of cool methods in here. If you familiarize yourself with what these things are, then you can save yourself a lot of lines of code, because NSString will just do things for you, Okay, that's a lot. And then each of the methods has very, detailed descriptions about what the return values are and what to pass to them and all that stuff. Obviously, you can search the documentation. Get used to the documentation. It's your best friend. You really, really, really want to spend time with that as you learn iOS 5. So again, we noticed that this was a property, so I'm going to change this to be dot notation as well. MyDisplay.text. Oops. Okay. I'm also going to, at this point, notice that I don't really need this local variable right here. Well, we'll go one more line first, and then we'll get rid of that. But so now I have the text. Now I need a new string, which is what's currently in the display with this digit appended on the end. So I'm going to say NSString new text, let's say, to make it short. And I'm just going to do this using a method on the string object called append string. So watch this. Current text string by appending string digit. Okay? So that's a string by appending string is a method in string. You send it to the string with an argument of another string, and it returns you itself with that thing appended on the end. Right? Exactly what we want. And now that we have the new text, we can say my display set my text to be the new text. All right? Now, what is this set text method? That is the setter that this is the getter for. So you see how I'm doing my display.text and my display set text? So I use dot notation here, so I'm going to use dot notation here as well. All right? So this is what it looks like to have dot notation for a setter. So I say my display dot text equals new text. And you can see that the dot notation is exactly the same whether you're doing the setter or the getter. It just matters which side of the equal side it's on. That's the only difference. Okay? Now let's get rid of a whole bunch of these lines of code. For example, my display, we don't need a local variable for that. We'll just take this little guy right here, which is its value, and we'll put it wherever we have my display. So that's here and here. Now, you might be a little freaked out here saying, whoa, 2 dots. But that's perfectly legal and very common to have 2 or 3, 4 dots in a row where you're accessing a property and then accessing a property of that property and a property of that property. Okay? So that's perfectly fine. So we don't need this anymore. Also, new text, we don't really need that local variable either. We'll just take its contents and put that right here. Get rid of that. And we don't even need current text, right, which is here. So let's just grab this, cut, paste, get rid of that. And so I told you there was one line of code, and there it is, one line of code. And you can see how the dot notation combines with the way Objective-C interlaces its arguments with the keywords, so that this reads somewhat pseudo-English-like in saying my display's text is equal to my display's text by appending on this digit. So it kind of has a little bit of read there, and Objective-C really tries in its syntax to be readable. Readability is really, really important in any kind of good code. Self-documenting readable code, really important. All right, so that's it for digit press. That's all we need to do. Let's go ahead and run again, and let's see if it works. So let's try it. 5, 8, 7. So it's working kind of, but I don't really like this 0 at the beginning. You see that 0 at the beginning? That's kind of yucky. And why does that happen? Well, that happens because we really only want to do this appending the digit thing when we're in the middle of typing a number. If we're in the middle of entering a number, we want to keep appending. But if we're not in the middle of entering a number, we want to start off a new number. Okay? So let's do that. Stop. So we need some private data now, a private property, which keeps track of whether we're in the middle of entering a number. So remember that I told you you can add private properties by doing this @interface, name of your class, calculator, view, controller, and then these 2 parentheses, right? So this is a space to create some private interface. And then I'm just going to create a property, non-atomic. It's going to be a bool. Bool is the Boolean typedef in Objective-C. Its value is either yes or no. No is 0. Yes is anything that's not 0. Capital Y, capital E, capital S, or capital N, capital O. Okay? And I'm going to call this variable user is in the middle of entering a number. Now, you all laugh, and understandably so, but having long variable names like this is really encouraged, and you're going to see why. Because once I've typed that once, now I go to synthesize it, synthesize user, I only have to type the first three things, hit tab, equals underbar user tab, okay? And so I'm quickly entering this thing without having to do much typing. And then how are we going to use this? User is in the middle of entering a number. Well, we're just only going to do this line of code, this self.display.text, if self.user is in the middle of entering a number. Okay? So we're only going to do it in that case. Sorry for the big font wrapping here. And if not, then we're just going to set our display's text equal to the digit. We're going to start off a new number. Of course, if we start off a new number, then we are definitely in the middle of typing a number, right? So we'll have to set user in the middle of entering a number to yes. Okay? So we need some more UI here, though. We need operation buttons. So let's put those in here real quick. Let's go up here. And drag out a new one because I don't want to copy and paste that same target action. Again, I'm going to hold down the control key, drag out, right, insert a new action. I'm going to call this one operation pressed. I need the sender for this one too because I need to see what kind of operation we're talking about here. I'll copy and paste to make 4 of these. All right. And we also need an enter button, which also I'm going to drag out because I don't want it to send digit or operation pressed. Okay, so we'll put enter on there. Oops, we better put some, say star, divide, plus, how about minus. Okay, so that's how we're going to know what operation we're talking about too. So I'm going to drag enter out as well. We'll put that in here. I told you I'd tell you about these things at the bottom. Actually, I'm only going to tell you about one, which is arguments. You notice that the arguments to our target action have always been the sender, but it's possible to actually get the sender and the touch event that caused the action to be sent, or to send nothing, which is what I want for enter because there's only one enter button. I don't need to have the sender to know what's going on. And then we'll call this enter pressed. And you can see no sender argument, you see, right there. All right, so we want to implement enter pressed and operation pressed, but actually we can't do that yet. Well, actually, before we do that, let's take a quick second here and just make sure that our user is in the middle of entering a number worked. So here's our 0. We press 5, and it starts off a new number. So that's good. It's working. Yeah?
What happens if you press 0 twice, for example?
You know, pressing 0 is like any other digit.
Well,
Like you started off with it, then it would start pressing 0. It would start with putting a 0, and then you press another 0. It would append another 0 on. 0 is no different than any other number. You could argue that it might be worth a little if in there to prevent leading zeros, but that's kind of up to you. This is a very simple calculator. We're not going to be doing a lot of corner cases, right? We're just going to, you know, do things. But in the back.
When you grab the NS digit, is that copying the sender title, or is that just data reference?
That's a very good question. So he says right here, where I'm saying digit equals sender current title, is that making a copy of that NS string, or is it giving me a pointer to that NS string? Okay, and that depends on how that property is declared. There is actually another thing like weak and strong, which is copy. Okay, and copy is basically strong, except for you're getting a strong pointer to a copy of it. And so we could go look at the documentation. I think current title probably copies, but it's kind of up to the property. Other questions? Back here.
Could we do dot notation for all of this?
Yeah, absolutely. That's a good question. Like current title, that is also a property on buttons. So we could say sender dot current title right here. So yeah, we could. We can, and we should. Not only could, we should. Any other questions? Okay. So now we need to do our model. Okay? Yeah.
So all these buttons, you drag them in.
Mm-hmm.
Is there another way to do this without the dragging?
You mean like in code? So the question is there any way to do all these buttons and stuff without doing it graphically? Sure. There's obviously code. You can create UI button. It's got, you know, an allocation and initialization method, blah, blah, blah. But you almost never do. You're almost always going to do it graphically because you want to be able to see what your UI looks like, you know.
So the follow-up question is, can we see what's being generated?
Okay, the question is, can you see what's being generated by these? And the answer is not really, because this is not a code generator. These objects are actually being archived off to disk, and when it runs, they're unarchived. Okay, they're brought in. There's no code being generated here. Okay, button just knows how to, save all of its attributes off onto disk, and then when you load the storyboard up, button pulls all those attributes out. And we'll talk all about that later. So let's talk about how quickly. Yeah.
For the function with argument, can we convert that to adopt?
Let's do that question afterwards. Because we're really short on time here, and I don't want to hold you guys too long extra. I am going to hold you extra, I'm sorry, but we need to get you going on this class. So let's quickly go and create our model, okay? Because we have our controller here, we have our view. That's great. Let's go quickly create our model. The way we create, I'm stopping the simulator there. The way we create our model is very straightforward. We go to the File menu, and we just say New File. Okay? Now, new file is a gateway to creating a lot of stuff in Xcode, not just new classes like Objective-C class or a new controller, which is what this is. But, for example, you can create a new database schema description, right, with this data model thing. So there's a lot in here, but today we're just going to talk about creating a new class. And we just click that new class. And we're going to call our model Calculator Brain. Okay? We could call it maybe Calculator Model, possibly, but I like Calculator Brain. A little more spicy. And we just want to make sure we put it in the same place that all our other files are. And here it is. It's created it. Again, now you can see that in addition to our controller, we have our calculator brain.m&h. I'm going to close that. I'm going to close this as well. And here you can see on the left is our implementation, and on the right is our header file. I'm going to start by adding a public methods. Now, this is an RPN calculator's brain, so it only knows how to do two things publicly, which is push an operand on its stack and perform an operation on whatever it's on its stack. So the two public methods would be push operand, which will take a double, and double perform operation. And we're going to use NS strings to specify our operation. This a little wider so you can see it. These strings are going to be the same strings that are on the buttons, which is probably really bad design, but we'll make it simple for this demo. But it's not necessarily bad to have your operation be a string, but to have them be strings that are directly in the UI, for localization and other reasons, you probably don't want to do that. But we're going to do that. So this is our entire public API, just these two methods. Notice that by adding these to my header file as public API, I actually got a warning here. See these little yellow triangles? We didn't take time out to talk about those when we were doing the other stuff, but these are warning. If you click on them, it'll tell you what the problem is. And it's doing this as you type. So basically, Xcode is constantly compiling, parsing, really, your code. And here it's correct that we have an incomplete implementation because we have these two public methods and we haven't implemented them. All right, so let's fix that. I'm just going to copy and paste them over here. And then I'm going to put some stub implementation. We do nothing there. And here I'm going to create a little local variable and return it. And like in between, we would, sorry. All right. Calculate result. Calculate result. Got a calculator on the brain. Okay, so there's our two public methods. That's great. Now to implement our brain, we're going to need that stack. Remember, we're keeping a stack of operations, and every time we press an operation, we pull off all the operations we need. How do we implement a stack? Well, a really easy way to implement a stack is using an array. Because an array of objects in most languages, and certainly in Objective-C, when you add an object to the end of it, it makes itself a little bigger. And then when you pull an object off the end, it makes itself smaller. And that's exactly what a stack does. Okay, so to push, we're going to add an object to an array. And to pop, we're going to remove the last object in the array. Right? The easiest stack implementation in the world is an array. So to do that, again, we need a private interface, because we're going to have a private property, because that stack is not public. When you push and operate and perform, the internal implementation of that is totally our models, and it's not public. So it's going to be non-atomic. Oops, sorry. Let me finish this. Calculator, brain, parentheses, end. Okay, so this is our private interface space. And then property, non-atomic. It's definitely got to be strong, because we're the only ones who are interested in this pointer. So we have to keep a strong pointer to it. And it's going to be an NS mutable array. Okay, and I'm going to call it operand stack, and I'm going to squish our public API way down. Okay, so here it is, our property. Now, mutable array, there's an NS array in Objective-C. That's an immutable array. In other words, you create the array with a certain amount of objects in it, and you can't change it. You can't add or remove any. And then a subclass of NS array is NS mutable array, which lets you add and remove, adds a bunch of methods for adding and remove. And that's clearly what we want here. Why do you think this yellow thing is here? Anybody know? Because we're not using it? Not quite. Yeah, because we didn't synthesize it, right? This is going to say you have no get. In fact, there's two errors here. If we press this 2, we'll see them both. It's saying, hey, you got no setter and you got no getter. So put those in there. So let's go down here. Synthesize operand stack equals underbar operand stack. Now I'm going to show you what synthesize would create. This is what synthesize is going to create for us. NS mutable array star operand stack return underbar operand stack, and then void set operand stack underbar operand stack equals this argument right here, operand stack. Okay? So for non-atomic properties, this is what synthesize, this is the code synthesize would generate, these two things. Okay? Now we don't need to put these in here because we have the synthesize. But I'm going to leave them here and you'll see why in a moment. Question?
Did override them like that? Would strong still do anything?
Yes, strong matters. Whether you implement it or not, strong is telling the compiler what to do with the memory that this pointer right here points to.
Okay, so it's not just strong generating the code for you, it's strong.
No, yes, strong is more than generating the code for you. It's a hint to the compiler to help you manage the memory. Or not to help you manage it, to manage memory for you. Okay, so push operand, let's do that one. That one's going to be super simple. We just get our operand stack. Oh, one thing I forgot to mention on Tuesday, very important. Accessing the instance variable, the underbar operand stack, you should only ever do in your setter and getter. Do not do it anywhere else in your code. If you need to get that thing anywhere else, use the setter and getter. That's what they're for. So here I'm getting the operand stack, and I'm going to call a mutable array method called addObject, because I want to add an object on the end of my array. That's how I'm doing stock. And I'm going to try to just add the operand, but of course, that's not going to work. And you see here now we have a red thing here, a red error. And what it's saying is sending a double to a parameter of type ID is no good. This is not an object, and mutable array only lets you add objects to it, not primitive types like operand, which is a floating point, a double. So we need to wrap that double in an object. And so we're going to do that by creating an operand object using this class NSNumber. So all NSNumber does is wrap primitive numbers in an object. Okay? So we'll say number with double operand. Okay? So now we have an operand object, and we can add that, and now our error is gone. And in fact, we don't even really need this local variable. We can just grab this and put it right here. Okay? And so with one line of code, we push something on our operand stack. Now, this line of code has a subtle problem. Okay? Here's the problem. What did I tell you that properties start out as when your object is created? 0, yeah, or nil in the case of a pointer. And what happens when you send a message to nil? Nothing, right? Nothing happens. So this line of code, this starts out as nil, so this line of code does nothing. Sending addObject to nil does nothing. So this is going to do nothing. That's bad. We don't want it to do nothing. Okay? So now you're probably thinking, oh, I need a constructor so that I can set that property to something. And yeah, we do have constructors in Objective-C, initializers we call them. But that's not actually the best place to construct this thing. Okay? The best place to make sure that operand stack is never nil is in its getter. Okay? We're going to go up to its getter. This is it right here. Conveniently, I showed you what it looked like. And we're going to implement our getter, and we're just going to say if operand stack equals nil, then operand stack equals, and I'm going to allocate, we're going to talk about how to do allocation, an array. So there is no way to get operand stack and have it be nil, because if it is nil, I allocate it. But I'm also only ever going to allocate it once, because once I've allocated it, then it's not going to be nil anymore. Everyone got this? This is called lazy instantiation, waiting until the last second to instantiate something that you need. Very common in iOS. So now I don't need the setter here because we're not going to do anything special in the setter, but I'm going to leave the getter. And synthesize is not going to synthesize a getter because we're doing it. Okay? And this is fine. So now when we do operand stack, this will never be nil. This getter can never return nil. Make sense? Yeah, question.
So
No. Synthesize never allocates something. That's a great question. Does synthesize allocate? No. All synthesize does is makes the instance variable for the pointer. But the things it points to, you got to allocate them. Question?
If you don't use non-atomic, then all the code it generates, you're overriding that code, so you're not getting it.
Correct. The question is, if I don't use non-atomic, what's going to happen? And the answer is, it's going to get a warning here. It's going to say, oh, you overrode the getter, but you didn't override the setter, and you're saying that you're doing locking for multiple threads. So it's going to actually give you a warning. It'll let you do it, but it's going to warn. You'll get a warning. So, okay. So by the way, we're going to run over here. If you have to go ahead and quietly sneak out. I have posted online basically what I'm going to do here, so you'll have to do it on your own. If you want to stay and watch me do it, that's cool too. But please be quiet on your way out for the people who do want to stay and watch it. Okay, so now we can do our perform operation here. Very straightforward. I'm going to make this a little higher on the screen so we can see it. All we need to do to perform the operation is, depending on what the operation is, we got to pop operands off the stack and do the operation. So I'm going to say if operation is equal to string, that's a string method, and I'm going to use a constant string here, just like I did with nslog. Then I'm going to say the result equals self pop operand plus self pop operand. And of course we're going to get an error here because we haven't implemented pop operand. But that's easy to fix. Let's go implement it. Double pop operand. And all we got to do here, get a number off the stack. Operand object equals self.operand stack. Last object. Okay, last object is a method in NSArray that returns a pointer to the last object. Not a copy of it, but just a pointer to it. So now we have that last object. That's awesome. And now we can return the double value of that by sending operand object, which is an NS number, double value. Okay, NS number responds to this message, double value, does it. Now, this is not going to be quite right because this is supposed to be pop an operand. This is really more like peek operand because it's only looking at the end of the array. We need to actually remove the last object, which we do with this NS mutable array method called remove last object. But it's a little more careful than that because if we try to remove an object from an empty array, not nil, but an empty array that we haven't put anything in yet, it's going to crash our program with an array index out of bounds. Okay? Last object doesn't do that because it's just peeking in there, but remove last object will crash your program. So we need to say if operand object. Oops, operand object. And we could say if operand object does not equal nil, or we could just say if operand object. Okay? Normally we would just say if operand object. Okay? See why we have to protect ourselves a little bit there against a crash? So here we popped it. Okay? So now since we're limited on time, I'm not going to put the rest of the operations in. However you can imagine them. Actually, I'm going to do one more because I want to show you another interesting thing here. What about this? Okay? Notice that I'm sending a message to a constant string. Is that okay? Absolutely, it's okay. Okay? Constant strings are just as much strings as anything else. So this is a string because it's an argument here, and this is a string because it's a constant string generated by the compiler. Okay? So don't worry about that. Perfectly fine. And then the last thing we do the other operations, any other operations, and your homework is to add some operations here. So hopefully you can intuit how to do that. But one thing we need to do is make sure that we push this result back on our stack because we want to be able to continue operating on it, the next operation that comes in. Okay, does that make sense? Everyone understand the model? That's it for our model. That's all it does. Let you push operands on and then perform operations. It pops off the ones it needs. Some operations might need one. Like if I did square root, which you have to do for your homework, it only needs one operand. So it's only going to pop one off the stack. And one operation I'm going to ask you to do, pi, takes no operands. Returns pi, but it doesn't need any operands to do what it does. So this perform operation can take as many operands off the stack as it needs to do its job, depending on what you're asking it to do. Right? These two need two operands, so we're popping two. Okay? And So that's it for that. Now we're going to go back to our controller and finish that off, which is going to be pretty straightforward once we have our model. So I'm going to go back to that by going up to the top here, this bar at the top, and go from calculator brain over to view controller. The first thing I need to do is import my brain into my controller. So this is my calculator view controller's implementation. I'm importing my model. Okay, so I can use it. On the right-hand side here, it's automatically, the assistant, the butler guy, has automatically decided that it wants to put the header file for my controller here. But actually, I don't want that. What I want is my calculator brains, my model's header file, because I want to use its public API. So to do that, you can go up here, and there's all kinds of assistant things you can get here. And one of the assistant things is, show me something I include. And since I added my calculator brain on the left, I can go over here and say, show me the calculator brain on the right. So now I can see the public API for my model while I'm working in my controller, which is kind of convenient. Okay? All right, so what we have left to do in the controller is these two guys, enter pressed and operation pressed. Now that we have this powerful model of ours, it's actually quite easy to implement this. So enter pressed is just going to push the thing. Right? It just has to push the whatever's in our display, just push that into the model. One thing we need to do that, though, is we need a pointer to our model. Okay? So almost all controllers are going to have a almost always private property. Not always, but mostly always. It's going to be strong. It's a calculator brain. And I'm going to call it brain. Okay? And of course, I need to synthesize it. Equals underbar brain. And you know what? I'm going to do lazy instantiation on it right off the bat. Okay? Calculator brain star brain. If not brain, if I don't have my brain yet, then brain equals calculator brain alloc init. Again, we'll talk about allocation initialization next week. And then I'm going to return my brain. Okay, so now, whenever I call the getter self, what did I do here? Anytime I call my getter, the brain will always be instantiated because I'm going to lazily instantiate it anytime anyone wants it. This is a great way to have your code pretty bulletproof because you can protect in your getter against cases you don't want of various properties. And it's also easy for people to understand. Usually people are going to go look in your getter to find out where things are instantiated for most properties. And if there's no getter, then they're going to be like searching around. Where is this thing? Initializer or something? So it's almost better to put it in the getter first. All right. So in enter pressed, we're just going to say self.brain push operand. And we need to push our operand. Well, it turns out an easy way to do that, we're going to get our displays text. Did everyone understand what I just did there? Self.display.text. Same thing we did above. Right? And I'm going to send that string the method double value, just like I sent the NS number. So it turns out not only does NS number implement double value, so does NS string. And NS string just tries to look inside of itself, and if hello is in there, it's going to be 0. But if you've got a number in there, it'll try and turn it into a double, so that's convenient. The only other thing I want to do here, though, is if I press enter, I'm not in the middle of entering a number anymore. By definition, I just entered it. So I'm going to say self.user is in the middle of entering a number equals no. Okay, and that's it for enter. Enter is easy one. Operation pressed, also easy. Okay, all we're doing in operation pressed is we're going to perform operation. So I'm going to say double result equals self.brain, perform operation, and I need to give it the operation. Okay, now I'm going to do the same thing here. I know a button is sending me this, so I'm going to change this to UI button star. Does everyone understand what I'm doing there? Same exact thing I did up here. Okay, I'm just letting the compiler help me more. It's only a compiler thing. And so now I need the string that is the operation. Well, the string that is the operation is, I know, bad design, the title of our operation button. Okay, so I'm just going to say sender.currentTitle. Everybody understand that? Okay, now I've got the result, but it's a double, and I need to turn that double into a string so I can put it into the display, because when I perform an operation, I need to display it. So I am going to create a string called result string, and I'm going to use a class method in NSString. We'll talk about class methods next week, called string with format, and it takes a printf-like format, and I'm going to use %g, which is a floating point number. Okay? and put the result there. So now I have a string result string, which is the result as a string. I use this string method to do that. Don't worry too much about this kind of strange receiver here, because this is not an instance, right? This is the class itself that I'm sending it to. But now I just need to say self.display.text equals the result string. Okay? There's only one other thing I'm going to do in Operation Pressed is I'm going to be nice to the user. If they type 6 enter 3 times, I'm going to press enter for them. So they don't have to go 6 enter 3 enter times. Okay, I'm going to save them an enter. If they're in the middle of typing a number, if self.user is in the middle of typing a number, then I'm going to press enter. Everyone understand what I'm talking about there? 6 enter 3 enter plus versus 6 enter 3 plus. And when I press that plus, it's going to enter that 3 that I'm in the middle of typing. Just convenience, purely convenience for the user. Okay, that's it. So let's run and hope I haven't made some mistake here somewhere. Here's our calculator now. So let's try 56 enter 3 times. I hope that's 56 times 3. 7 divide. Oops, I didn't implement divide, so I got 0. Okay, so that's the right thing. 36 enter 2 plus, 3 plus. So it's working that when I add things on, 6 plus, that's working as well. Okay? Okay, that's it. Everybody got it? Any last second questions? I'm sorry I went over by 10 minutes. I hate that, but hopefully you all got it. Thank you very much.
For more, please visit us at Stanford.